Hello! Whoa, 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 whoa! Algebra students, Mr. Laurence here, and we're winding down the year. A couple more quick things to learn. Now, the last video you saw was on parallel and perpendicular lines. It's going to look like we're doing something totally different, and maybe we are. But in the next video, I'm going to tie together what we did in the parallel perpendicular line video to this point slope form. This is another form of a linear equation. Remember, we know standard form ax plus by equals c, and we also know slope intercept form y equals mx plus b, but now we need to know point slope form. It's going to make doing these parallel perpendicular problems real easy. First of all, point slope form looks like this. Y minus y sub 1 equals m times the quantity of x minus x sub 1. Should look like a little bit like your slope formula. You know, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Very similar. If I multiply this fraction to get rid of the denominators, I end up with this equation. Yeah, that's crazy. Now, why do you suppose they call it point slope form? Well, for the same reason they call this green one slope intercept form, because we know the slope and the y-intercept. Well, this black one here, y minus y sub 1 equals m times quantity of x minus x sub 1. It's called point slope form because when it's written in this form, we know the slope, which is m, and we know a point, which is going to be x sub 1, y sub 1. By the way, did you notice that they changed signs? The x sub 1 had a negative in front of it. There it's positive. The y sub 1 had a negative in front of it. There it's positive. They change signs. So take a look at problem number 1. I want to know the slope of this equation. Well, it's 1/2. Piece of cake. Look, it's sitting y minus y sub 1 equals m times the quantity of x minus x sub 1. And see, m is sitting right outside that quantity. I also want to know a point that the line goes through. It's not going to be the y-intercept. It's going to be a different point. So, let's see here. The x-coordinate is found here, and it needs to change signs, so it's going to be a -3. The y-coordinate is found here, and it needs to change signs, which means it's going to be a 7. There you go. I've got the slope and the point just from that equation. If I wanted to graph, I could graph this point, -3, 7, and then rise 1, run 2, rise 1, run 2, rise 1, run 2. All right, here we go. Problem number 2. Tell me the slope. Mr. Reed, shout it out. I can't hear you, Josh Reed. Why aren't you shouting it out? You better be watching. You better not be sleeping or picking your nose. All right, the slope is -3. All right, Mr. Conwell, what is the point? The point is, come on, Joey, I know you can do it, 4, -6. Mr. Merrick, did you catch that? The 4 was negative, became positive. The 6 was positive, became negative. They changed the signs. All right, very good. So when it's written in this point slope form, we can just know a point and a slope without doing much of anything. If you wanted to, you could distribute and then subtract 6 from both sides, and you'll go to slope intercept form, but you don't have to do all that work. All right, now, if I gave you the slope and a point, could you write the equation in point slope form? Remember, point slope form looks like this. Y minus y sub 1 equals m times the quantity of x minus x sub 1. Oh dear, oh dear. Get back up there. All right, so let's give it a shot here. I need y minus the y-coordinate, -1. Oops, not a comma. No comma there, silly Mr. Laurence. Equals the slope times the quantity of x minus the x-coordinate, minus -6, which is a +6. Notice it changed signs. The 1 was positive, became negative. The 6 was negative, became positive. There's the equation. That's the linear equation for the line that runs through the point -6, 1 and has a slope of 2/1. All right, number 4. I'm going to have y. I need to subtract the y-coordinate, which means I'll be adding 2. And then the slope will be -4/3. And then I'll have x minus the x-coordinate and I mean points in a form. That is it for the video. This is simple stuff. We'll get a little practice, and then tomorrow we're going to tie this in with the parallel and perpendicular problems. Now, by the way, you have that take-home quiz. Please feel free to email me with questions. Okay, hopefully you've been doing that. All right, Mr. Laurence signing off. Have a good night, everybody.